Okay, how's it, Chase? Hope everything's going well. Welcome to another video lesson. Today we're going to be doing section 4.6, and this section is half angle identities. So once again, you'll remember what an identity is from the previous video. And the half angle identities is just another set of identities that you can use to help you solving trig problems. It's half and double angle identities belong together, so we're going to probably look at both of them here. So, okay. Half angle identities are identities in the form that have the argument theta over 2. Okay. So let's just take a look at one of the examples here. It's actually not an example. What it is a bit of a proof on where they get the half angle identities from. And basically where it comes from is very simple, so I'm just going to explain it to you. I'm not going to go through the whole proof because I think that would be a bit of a waste of time. I don't think they'd ever really ask you to do it. Just double check in your exam, past exams, but it's very simple. So we're just gonna take a look at them quickly. Okay. So the half angle identities are as follows. Sine of A is equal to 2 sine A over 2 cos A over 2. Alright. And cos A is equal to cos squared A over 2 minus sine squared A over 2. I wonder if they're going to give you these in your formula sheet. You should just double check, because if not, you're going to have to memorize these, which is going to start becoming quite difficult. Okay. And then we've also got this one, cos A equals 1 minus 2 sine squared A over 2. It's another identity. And we've got cos A equals 2 cos squared A over 2 minus 1. I don't see them making you have to remember all of these because there's really a lot of them. So, okay, we've got sine A equals 2 sine A over 2 cos A over 2. Cos A equals cos squared A over 2 minus sine squared A over 2. Cos A equals 1 minus 2 sine squared A over 2. Cos A equals 2 cos squared A over 2 minus 1. We've also got, okay, these next two identities I think come from, let me just take a look here. I'm sure that these are just a simplification of, yeah. Okay, so if we take this identity and just rearrange it, we also find that cos squared A over 2 is equal to 1/2 cos A plus 1 I'll leave the rearrangement to you, but basically take this one rearrange it, making cos squared A over 2 the subject of the formula, and you end up with this identity. And then we've also got sine squared A over 2 is equal to 1/2 1 minus cos A. Okay, which comes from which identity? Comes from this one. So if you rearrange this identity, you're going to end up with that. Okay, so let's quickly jump into some of the applications of these half angle identities. Okay, so let's see. Example 5. Okay, example 5. Find the value of sine squared A over 2 if cos A equals 0,5. And they say no calculator in C. No calculator. Okay. So, what are we going to do here? We need to find this, the value of this, given that we know that. So we can just go to our identities and find one where this, sine squared A over 2, is the subject of the formula, and where, so basically this should be on the left hand side, and this, we need to look at an identity that has cos A on the right hand side, and only cos A and other real numbers, but no other trig functions. So this should be on the right hand side. So if we quickly go look at our list of them, let's find one. Okay, look here. Sine squared A over 2 we said must be on the left, and we said cos A equals 0.5, so cos A must be on the right, and we've got cos A there. So if we substitute 0.5 in for cos A here, then we can solve the right hand side, and then we know what sine squared A over 2 is. So let's do it. Okay, so from this identity, sine squared A over 2 is equal to 1/2 1 minus cos A. Alright? And we know from the information given that cos A is equal to 0,5. So let's substitute that in quickly. So we've got equals 1/2 of 1 minus cos A is 0,5, which is equal to 1/2. 1 minus a half is 0,5. A half times 0,5 is 0,25. This should have been green. Okay, so there we go. And now we've solved the problem. Sine, I'm going to do that in red. Sine squared A over 2 is equal to 0.25. And there you go. Nice and simple. Right, let's move on. Example 6. Okay, where's the question? Find the magnitude of B if 6 sine squared B over 2 is equal to 4. 6 sine squared B over 2 is equal to 4. Okay, so once again, we know that 6 sine squared B over 2 is equal to 4. So let's go back to our list of identities and find something that's in, squared. Find something that's got the form a sine squared b over 2 in it. That's going to be our first step. Okay, so I'm actually just going to look it up here. So the identity that we can use is the last identity. In your book it's called I14, and that doesn't equal I14, which says sine squared a over 2 is equal to 1/2 1 minus cos a. So can you see that this, I just want to check here if they said no calculator, because it doesn't look like it's. They actually didn't even do it this way. That's interesting. Okay. In this problem, they didn't use a half angle identity, but I'm going to use one just for the sake of it, because we can. Either way, I'll show you both solutions. So let's just simplify what they've given us here. So we're just going to take this 6 across to the other side. So we're left with sine squared b over 2 equals 4 over 6, which is 1 over 3. No, 2 over 3. Okay. That's all good and well. Right. So now, can you see that the left-hand side of this equation is the same as the left-hand side of that equation? Okay, and the right-hand side of that equation, this equation here, must therefore be equal to the right-hand side of that equation, because we know that sine squared b over 2 equals 2 over 3. We also know that sine squared b over 2, or a over 2, is equal to 1/2 1 minus cos a. So what we can draw from this is that sine squared b over 2 is equal to 2 over 3, which is also equal to 1/2 1 minus cos a. Alright? So let's use this part of the equation, because we only need one equal sign, we don't need two. So let's carry on. 1/2 1 minus cos a is equal to 2 over 3. Okay, so let's just start simplifying that until we can solve for a. Because they asked us to find the magnitude, or actually this is cos b. We need to find the magnitude of b. So take the half across, that is going to become 1 minus cos b is equal to, if we divide 2 over 3 by half, we end up with 4 over 3. Okay. Then we're going to take this 1 across. So negative cos b is equal to 4 over 3 minus 1 is 1 over 3. Cos b equals negative 1/3. Okay. Then we're going to take cos inverse. So b is equal to cos inverse of negative 1 over 3. Okay. So if we pop that into our calculator, which I actually don't have on me, so here we're going to use the computer's calculator. There we go. Let's just get this guy into scientific mode. This calculator has changed since Oh, there we go. Arc cos, sorry, I haven't used this calculator on Windows 10 before. It's freaking me out. I don't know how to clear this stupid thing. Yeah, okay. So, let's put in negative negative 1 divided by 3, okay, and then we're just going to take cos inverse of that, and B is equal to 109.47 degrees. Okay, so we've got our angle, but now there's something to remember. I don't know if you remember this from high school, and that is the cost rule. Okay, C-A-S-T. Okay, which says cos is positive in this quadrant, all are positive here, sine is positive here, and tan is positive here. So we've found our angle B at 109 degrees, which is somewhere here. Okay, that's about 109 degrees. Okay, but you see, cos is negative. We said here cos B is negative a third. There are two quadrants where cos is negative. Cos is negative here, and cos is negative here. Okay, so essentially there are two answers, and in order to get those answers, we need to cos is negative there. We need to add 90 degrees. Okay, so our other answer is B. So B equals 109.47, or B equals 109.47 plus 90 degrees equals 199.47 degrees. I see that is different from the answer in your book, so let's just check out why. Okay, I'm not actually sure. This answer is not 100% correct. Okay, we'll have to figure out why. I'm not sure yet. I just want to show you the other method of doing this problem, and this is the method that's in your book. Because you see here, I used this half angle identity, assuming that's what they wanted, but there is another way to do it. So let's do it that way as well. Okay, so once again, we have been given 6 sine squared b over 2 equal to 4. Okay, so why don't we just simplify this and solve for b. So that's what your book did. So they took the 6 across. Sine squared b over 2 is equal to 2 over 3. Okay, then we take the square root to get rid of this square. So sine b over 2 is equal to plus or minus square root of 2 over 3. Remember, when you take a square across an equal sign, you always pick up a plus minus, which means that sine b over 2 equals root 2 over 3, or sine b over 2 equals negative root 2 over 3. Okay, so that is equal to 0.816. Okay, now let's take sine inverse. So sine inverse b over 2. So b over 2 is equal to sine inverse of 0.816, and or b over 2 is equal to sine inverse negative 0,816. Okay. So now, if we pop these into the calculator, we find that b over 2 is equal to 109,47, or b over 2 is equal to 250,53 degrees. Okay, then we're just going to take that 2 across, and that says b is then equal to, b over 2 here is equal to 54.74. And here, sorry, I skipped the line of work there. B is equal to 125,26 degrees. Okay, so if we just take the 2 across, we're left with B equals 109,47, or B is equal to 250,53 degrees. Okay. Alright, you're probably going to have some questions about this problem if you work through it. And just work through the problem, read it in your book. It's example 6, page 411. If you've got any questions about it or about what's going on in the book, just drop me a message, and we will we'll take a look at it and discuss it, and I'll explain in detail. It's a bit of a difficult one to actually explain on this video, so we can discuss it more in person next week. I'm going to call an end to this video now, and then tomorrow I will do another one and finish off this half angle identity section. Cool. Thanks for watching, Chase. Cheers.